Hello everyone. Today we're going to solve a problem from the movie Super 30 where they say there are 30 people in a room. They're shaking hands with one another, and after they have all shaked hands with every other person, they have to count how many hands have been shaken. Sorry, how many handshakes there have been. So to solve this problem, we must think about another problem beforehand. Trust me, this will make sense. When Gauss, the mathematician, was 10 years old, his elementary school teacher gave him a problem. Add all the numbers uh, from 1 to 100 and tell the answer. So every other student in the class except for Gauss um, added them by brute force, but Gauss found the answer 5050 in just a couple of minutes. He realized that if we add the first and last number, we're getting 101. If we add the second and the second last number, which will be 99, he's also getting 101, and so on until all the pairs have been finished. How to get the pairs that may be formed in this series? It's just the length of the series, which is 100, upon 2, because we're finding the pairs, and then we multiply it by the sum so that we may know the total. The sum is just 100 plus 1, the first and last series, which is just 101. If you solve this, you will get 50, because we're dividing, into 101, and that will give us the correct answer. And this is what Gauss did. If we want to express it with variables, you can just take any series, 1 plus 2 plus 3 dot 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 x. X is the length of the series. We divide it by 2 to find the pairs, and the sum will be x plus 1. Some people call it the Gauss theorem or something, but it's actually not the Gauss theorem. It's not called that officially. And it was not actually Gauss who discovered this. He just did it when he was 10 years old. It was actually the ancient philosophers who had already found this out. So how does this help us in solving the Super 30 problem? Well, imagine there are 5 people instead of 30 shaking their hands in a room. There will be 4 people on one side, and let's assume that one person goes up to shake hands with everyone. So that's 4 handshakes in 5 people. We get 4 handshakes plus all the handshakes these other people will be doing. So suppose this person goes away from the room because everyone has already shook their hands with him. This person comes ahead in the room and then shakes hands with everyone else. That's 3. And you can see that it reduces by 1 every single time. Then this person will come up and shake hands with these 2. Then this person will come up and shake hands with this one. So plus 2 plus 1. And if we add it, we will get a total 10. We will get 10 as the total. And if you want to express it in variable terms, what we can do is assume an x number of people, x people, and let's suppose these are the x people. So x minus 1 is the first matchup, we can call it, for handshaking. Then that person goes away from the room, the other person comes in, and there is one less person he has to shake hands with. So that's x plus x minus 2 in brackets, and that goes on, x minus 3, etc. until a time comes when there is minus x minus x minus 1 people in the room. So that means that almost everyone has shook their hands except for the last person. This is the number of handshakes for the last two people shaking the hand. And this we can simplify. This is actually just 1 plus 1. If you observe carefully, you can see the same pattern as that of the thing that Gauss did earlier. Um, the length of the series is x minus 1, x minus 1. Then the pairs in the series will be x minus 1 upon 2. Then the sum of the first and last part will be x minus 1 plus 1, and that's just x. So we multiply this like this, and we get the answer for how many handshakes there have been. Right. In the super 30 case, there were 30 people. We use this, it gives us 30 minus 1 into 30 upon 2. This simplifies to 30 minus 1 into 15, because we are left with 15 here. And it's 29 on this side multiplied with 15. If you do the math, we get 435 handshakes. And that is how they find the answer to the problem. How many handshakes have taken place in a room of 30 people, where each person has shook their hands with another. Now we will find the geometric proof of x into x plus 1 upon 2, which is applicable for this series, where x is a natural number. To find the geometric proof, we must understand a concept known as triangular numbers. Basically, what these triangular numbers are, they are represented by a set of dots. This is a dot, it represents 1. There are 2 dots below it, it represents 2. There are 3 dots below it, represents 3, and so on until x. Let's assume this is x. Don't take the value. And you can see that it forms a triangular shape, and that's why they're called triangular numbers. But if you decide to make a grid-like structure for these triangular numbers, you can arrange them like this: 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. You get this right angle triangle. But to make it in a grid-like format, we give an area of suppose 1 unit per dot. Let me just make the grid over here. Okay, there is our grid, and we can actually take the grid, and if we find each area, 1 unit of area represents one number, 1 as the number, so it's 1 unit square. So if we find the diagonals of each of these squares to form a perfect right angle triangle, we can find out the area of this triangle. The height of this triangle will be whatever this number will be. Let's say x. X is actually just the sum of the sides of these each squares, which is like 1 unit. But don't go after the number. We are trying to find the answer in the variable format. So this side is 1, and this side is x, and this side is also x. And the formula for the area of a triangle is half base into height. The base is x, so half x into x, and we're adding this to the area of these little dots. Each of these is half of one, so this is the area of a single one of these. But if you need to find the area of the total, if you count the total, you will get x of these half squares. So half x is the area of these. So we're adding half x, x upon 2, and you can see that we can take x upon 2 out by factorizing. So x into x plus 1 upon 2, because you can see that this is just x squared upon 2 and we're adding it to x upon 2, and we just remove x upon 2 out of this to factorize it, and you get the same thing as this. This is the geometric proof of this x into x plus 1 upon 2.